I'm going to correct exercise 2 in your paper, okay? And it says that the sun is 150 million kilometers away from the Earth, okay? Which is the same as saying that is 1.5 times 10 raised to, the comma is here, okay? It's going to be 1, 2, 3, 4, 5, 6, 7, 8 raised to 8 kilometers, okay, from the Earth. And it says calculate the minutes, time in minutes, the light takes to travel from the sun to the Earth. And you know that the speed of light is 3 times 10 raised to 8 meters per second. What do I have to do the first? My units are kilometers, meters, seconds, and I have to calculate the time in minutes. So I have to put these units in kilometers per minute, okay? So first of all, we are going to do conversion factors, and we know that 3 times 10 raised to 8 meters per second, we have to put it kilometers per minute. So meters is above, so I'm going to put it below. So 1 meter equals, have to put into kilometers. 1 meter is 0.001 kilometers. And now secondly, we have to put seconds, so 1 second. It is below, so I'm going to put above 1 second. And I have to put it into minutes. 1 second equals, you know that 1 minute is 60 seconds. So 1 second is going to be 1 divided into 60. Okay? 1 divided into 60 equals 0.016 periodic. So now we multiply this times this and we divide it into this. So it is going to be something like I'm going to do it, and it is divided upon times 0. This is and this equals 18, okay? 18 kilometers per meter. And now, per minute, sorry. And now, with the formula of speed, of velocity, we can calculate it. So we know that velocity equals position or displacement divided into the time. We have to calculate time. So we know that the velocity of light is 18 kilometers per minute, and that the distance is 1.5 times 10 raised to 8 kilometers. This is kilometers per minute. and here we are going to guess time in minutes. So we solve the equation. This is dividing, so goes here multiplying, and it is going to be like this. Time equals 1.5 10 to 8 divided into 18. So time is going to be divided into 18. 8.3 minutes. It takes the light, it takes 8.3 minutes, the light reaches the sun, reaches the earth from the sun. In exercise 13, we have a graph and it asks, which one move faster? Okay. Obviously, A. Which one moves faster? A. Why? So simple. It starts as in 10, okay, at 10 meters. And B, as the time goes by, B is increasing its position slowly, as you can see, okay? And in the case of A, as the time goes by, it is increasing its position faster, okay? The increase of position is here, and you can see that the increasing of position is higher in the case of A, so it's moving faster. If the line is straight, okay, if it's a straight line, it's because the speed is constant. But if the line is not straight, it's because the speed is not constant. It is accelerating or decelerating. So as the time goes by, it increases its position, but the speed doesn't increase, okay? If the speed increases, what is going to happen is this, that the line is not going to be straight. It starts here, and it starts slowly, okay? It increases its position, okay, but slowly. But now it accelerates, so the position is going to increase faster. So the time goes by, okay, but the position increases faster, okay? It's going to have this shape. Maybe this sounds you. It sounds you to coronavirus, the number of infections. Infections at the beginning start slowly, and as much people are infected, they can infect more people, so the infections are increasing faster and faster and faster and faster, okay? The same happens with the speed. The speed is going to increase faster if you are accelerating. If you start slowly, slowly, and then you increase it, okay? And B, calculate the velocity of each one. Okay, velocity equals, and remember, please remember this. You know that velocity is the increasing of position divided into time, okay? The increasing of position is the same as saying final position minus the initial position divided into time, okay? Remember this formula, okay? So speed in A is going to be final position 16, initial position 10, and the time from here to here it's 2 seconds. So 16 minus 10 is going to be 6 divided into 2, which is 3. This is time in seconds, and this is position in meters. 3 meters per second. And the speed or velocity in B is going to be final position 14 minus the initial position, which is 10, divided into 2 seconds. So it's going to be 4 divided into 2, which is 2 meters per second. That's right. And now, see, we have to see one of them ask for the equation of each one, forget about that, and the other one, where's the object A after 5 seconds, and what about the object B? Okay, object A is going to be, we know that the speed equals final position minus the initial position divided into time. So in the case of A, okay, we know that the velocity of A is 3 meters per second. 3 equals the final position, which is what we want to know, because we know that it's going to pass 5 seconds. Time is going to be 5, and final position is what we don't know, and the initial position is 10. Okay, we solve this. 5 comes here multiplying. 5 times 3, it's 15, equals minus 10. And now the final position is going to be 15 minus 10. So final position is going to be 5 meters. No. Final position is not going to be 5 meters. It's going to displace 5 meters, okay? The displacement is going to be 5 meters. So final position... Oh, I made a mistake. If this is minus, it goes plus. So it's going to be 25 meters. Okay? And now, in the case of B, it's going to be the same. Okay? Okay. So, velocity in B is 2 meters per second. Okay? 2 meters per second equals final position, that is what we want to know, minus the initial position, which is 10, divided into the time, and time is 5 seconds. So this goes multiplying, and this comes here summarizing what I'm going to write it here like this, minus 10. And now 5 times 2 is 10, so 10, and here comes here plus, is 10 plus 10. So final position is going to be 20 meters. And so that's all. Take care about conversion factors. As you can see, if you don't know how to use conversion factors, you are going to fail. And also, if you don't know how to use scientific notation, take care and review it, please. And by the way, this is not so difficult, but tomorrow we are going to start learning the accelerated movement. Remember, the position time graph in an accelerated movement is going to be, but only position time, okay? not the speed time graph. Okay, so that's all for today.